Hello everyone, welcome to Tan45 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithms in Java, and today's topic is merge sort. So unlike the earlier sorting algorithms that we have covered, merge sort is more advanced, and this video might be a little longer. I know we are more accustomed to shorter videos, but merge sort is really important, very frequently used, and since it has a better time complexity, it's used in applications as well as very common for interviews as well. So please pay attention and let's understand merge sort. So merge sort is a divide and conquer algorithm. Okay, it works by dividing the arrays into two halves, recursively sorting them, and then merging the sorted halves. It is a stable sort. Merge sort maintains the relative order of equal elements. I'll explain you what it means. Okay, let's take an example. So let's say we have the input. We'll say input. Okay, we have the input 12, 11, 13, 5, 6, 7. Okay, and of course the expected output is 5, 6, 7, 11, 12, 13. Okay, now merge sort is a divide and conquer algorithm. It works by dividing the arrays into two halves. So what it does is divides the algorithm into two halves, then sort the halves, then merge them up again, and it does it recursively. So it divides the array into shorter and shorter halves. We'll go through that. Now what do we mean by it is a stable sort? So what happens if, let's say, your input was something like this, 12, 11, 13, 5, 6, 7, and you had one more element. Let's say after this there is another 12. Okay, now let's say all these elements have another value associated with them as well: a, b, c, d, e, f, and g. So by stable it means this 12 will come before this 12 in the sorted output as well. So the sorted output would be 5, 6, 7, 11, 12, 12, 13. Now this 12 is the one that is holding A, and this 12 will be the one that is holding B. Since it's relatively, it comes first in the input as well, so it is kept first in the output as well. This can be actually used when you don't only want to sort on the numbers, but you want to sort on a second parameter as well. So it keeps the relative positions intact. Okay, let's go back. Now let's see how merge sort works. Okay, we'll clean up our space here a little. Okay, so it says the array is divided into two halves until each half contains only one element, base case. Then these individual elements are merged back together in sorted manner. So if you try to understand, it is really easy. First it divides, it conquers, and then combines. Okay, so what happens, we'll divide this array into two parts. Okay, so this is one array and this is another array. Now this further gets divided into two parts, 12, 11 on one side and 13 on one side. This gets divided into two parts, 5, 6 one side and 7 one side. Okay, now again, since this is single element, but this one will again get further divided into two parts, 12 and 11. This again further will get divided into two parts, 5 and 6. So we have recursively divided it, right? So our divide is done. This is our divide, that is done. Okay, now it conquers, it sorts the two halves recursively using merge sort, and in the end it combines. So what happens, we have divided, we have reached to last elements when there is only one element per array. So it is an array of containing only one element. Okay, now these are the elements that we are left with. Now it will start going up again and start merging them. So first at the lowest bottom it merges these two, 12 and 11, and during the merge it sorts them. So 11 comes first and 12 comes second. So it will be 11, 12, this will be an array after layer 1, and here we will have 13, then we have 5 and 6, they are merged. So 5 is still before 6, 5 and 6, and we have 7, right? Now these two arrays will get merged and these two arrays will get merged. Okay, we will go down a little. Okay, so now it will become 11, 12, 13. So first 13 is compared to the first element 11, it is bigger. Then this moves to next pointer. 12 is compared to 13, it is still bigger. So we first copy 11, 12, then we copy 13. This becomes one array. On the other side also, they are sorted during the merge. So 7 is compared with 5, 7 is bigger, it moves next. 7 is compared with 6, 7 is still bigger. So we know the order 5, 6 and then 7. Now in the end these two are merged. So first we compare 11 with 5. 5 is smaller, we get 5. Pointer moves forward. 6 is compared with 11. 6 is smaller, we get 6. Pointer moves forward. 7 is compared with 11. 7 is smaller, we get 7. And since all the elements from this array are complete, we directly copy all the elements from this one because there is no one else to compare and this array is already sorted. So we directly copy 11, 12 and 13. Okay, so this is how we get our answer. So we have to do three things: divide, conquer and combine. Okay, let's go through the code and understand how we are going to perform our operations to perform the overall merge sort. Okay, the example is clear. Let's go. Okay, too much. Okay, so we'll create our function for sorting. So since it is going to call two parts, one would be the merge sort. Why? Because we are going to recursively call this merge sort again and again on a smaller array. Initially the merge sort was called on this complete input and then it divided into two parts. Now we want to call merge sort on this part and on this part as well. Then subsequently we want to call in this part and this part as well, right? So we'll have main method. We'll say main function that sorts an array using merge sort. This will be the method that we'll be calling from our main method. So we'll say public void merge sort. We need the array. We need the starting index and the end index. Why do we need the starting index and the end index? To keep track of these smaller arrays inside the main array. Okay, so we'll have the starting index int left and then int right. Okay, of course this would be 0 from the input side and this would be array length minus 1 from the input side. Okay, now we'll check if left is less than right. So if only one element is there, we don't have to perform this operation, right? But if we have two elements, 12 and 11, there are two elements, right? Left is smaller than right. So if left is smaller than right, we'll divide them again into smaller parts. Okay, so we'll say find the middle point. Int mid is equal to left plus right whole divided by 2. Okay, now we are going to call recursively merge sort on the left half and the right half. So we found the midpoint, right? From the input standpoint, if you see, this is index is 0, 1, 2, 3, 4, 5. So if you see 0 plus 5 divided by 2, it is equal to 5 by 2 is equal to 2. So our midpoint is 0, 1, 2 at 13. So we'll take all the elements on the left hand side and all the elements on the right hand side and call merge sort again. Okay, so let's see. So we'll say recursively sort the two halves. So we'll say merge sort, will pass the same array. Left will remain the left, but the right would be mid, right? Similarly, we'll call on the right half merge, array will be same. Mid is considered, so mid plus 1 and right. Okay, so it will recursively call the merge sort on this one. But once the merge sort has been called, this function has been called, it reaches its stage where it has recursively left side has been called, the right side has been called, and we are imagining that once it returns back from this side, this left half would be sorted, the right half would be sorted. So we would want to merge them, right? So we'll call merge the sorted halves. So we'll say merge, we'll pass array left, mid and right. Okay, so here at this stage, when we have reached the bottom and from one side we have only 12 left, on the other side we have only 11 left in the two halves. Let's say this is left half and this is right half. We have only two elements, so 12 will be merged with 11, and inside the while we merge we have to sort them. So that functionality will perform in the merge operation. And once 11 and 12 are merged like this, the recursive call will go up, and then it will merge this array to 13. It will go further up, it will merge 11, 12, 13 to 5, 6, 7, and the same thing would be happening for the right hand side of array as well. Okay, so we have divided for the left half, right half. Whenever it is done, we'll merge them. This is all that we need in the merge sort function. Okay, now we want to merge the two halves. While merging the two halves, we have to take care of sorting them. Okay, so let's we'll say function to merge two halves. Okay, so public void merge, we need int array, int left, int mid, int right. Okay, so for little clarity, I'll keep it here. Our input looks like this. We have 12, 11, 13, 5, 6, 7. Okay, it is first divided into 2. This part comes 5, 6, 7. This is divided into 2, 5 and 6 on one side and 7 on the other. This is further divided into 2, 5 on one side, 6 on one side. Okay, so these are the end elements for right half. This is right half. Okay, now so we want to merge, so we can imagine that the two halves have been sorted. So these two halves could be these stage. So in the end we have left array that contains only 5, right array that contains only 6. So this would be right half and this one would be left half. So while merging them, we have to sort them again. Okay, so we'll create the sizes for the two sub arrays, either on the left side or on the right side. So we'll say find sizes of two sub arrays to be merged. Okay, int n1 for the left half would be mid. We have the mid minus left plus 1. Okay, if you see in this one, if we consider this complete as left half, our mid was here. Okay, so our formula is in n1 size is mid minus left plus 1. So mid was at 0, 1, 2 minus left is 0 plus 1 is equal to 3. So left half size is 3, 1, 2, 3. That is correct, right? Similarly, we'll calculate for the right half size. Int n2 is equal to, what should be the right half size? Simply right minus mid. Okay, now we'll create two temporary arrays. So create two temporary arrays, or you can call them auxiliary arrays. Wait, once again. Okay, so we'll say int left array is equal to new int of size n1, and then similarly int right array is equal to new int of size n2. Okay, up till here we are clear. Now what we'll do, we'll copy the data from this main array up till 0 to left to the left sub array and 0 to right to the right sub array, so that we have the data in another temporary array, and while picking out the data from the temporary array back to the main array, that is the time we'll sort them. Okay, so we'll say copy data to temp arrays. So for int I is equal to 0, I is less than n1, I plus plus, I plus plus. Okay, and we'll say left array of I is equal to array of left, that is the starting point, plus I, right? This left is this left, that is the starting point. So when we are merging these two, only 5 and 6, this is our left, so left plus I in this case only be 0, and right plus I in this case would only be 6. So we'll copy all the data to from array of left to a temporary subarray. Similarly, we'll do it for the right side. So for int j is equal to 0, j is less than n2, j plus plus. Okay, and we'll say right array of I is equal to right array of j is equal to array of midpoint plus 1 plus j, right? Because our mid is here, but the right array starts from 5, so mid plus 1 and then plus the value of j for copying 5, 6 and 7. Okay, so mid plus 1 plus j. So we have copied the right subarray as well. Excuse me. Now we'll start merging them. So we'll start copying the arrays back to the original array, and in the process we'll sort them as well. So we'll say merge the temp arrays back into main array, that is from left till right. Okay, so we'll initialize few variables. In I is equal to 0, j is equal to 0. We'll initialize the initial index. We can always merge from the left hand side and the right hand side. So we'll say we need one more initial index of merged array. Okay, so initial index will be k, int k is equal to left. Okay, so why k is equal to left? Imagine this, we had our initial array, right? We had our initial array, we had the values 12, 11, 13, 5, 6, 7. Okay, we came down, and now we are going to merge them back again, right? This is the starting index of right half, this is the starting index of left half. We have to and these you can imagine they are copied into they came all the way up after sorted, and we are already at the stage where they are copied into two subarrays. One is 11, 12, 13, other one is 5, 6, 7, and these are temp arrays. So temp 1 that is left array and right array. So we want to merge it back to the original array, and the original array had values something like this: 12, 11, 13, 5, 6, 7. This is not required. So while merging them back, we want to keep a track of where are we actually inserting those elements in this array. So we need another index for this main array. That index we are representing by k. Okay, so for that we have another variable k. What happened here? Okay, so int k, it is initialized with the left hand side. So while now we will compare on the left side also and all the right half also. So while I, that is index for left subarray, is less than n1 and j is less than n2, because it could happen, let me clear some space. Okay, it could happen that on the left hand side in the left subarray we have two elements, like it will happen here. We have 11 and 12, and in the right subarray we only have 13. So first we compare the elements. As long as j is less than n2, that is n2 in this case is 1, and length of this is 2, and I is less than n1. So for values 0 and 1, the moment this breaks, so when we have compared 11 with 13 and it breaks, 11 moves to 12, but let's say this was 10, so we directly copied 10 and this array is over. We'll come out of the while loop and this 12 would still be remaining, or all these elements would still be remaining, and we'll one by one copy all the remaining elements on the right side of this, because we'll have 10, and on the right side we'll copy this complete array 11, 12. Okay, so so that's why while merging we'll check for the values from both the arrays. We'll compare 11 with 10. Since 10 is smaller, we'll get the 10, but as per original value it was 13, so 11 with 13, 11 is smaller, we get 11. Then this index will move forward, 12 will be compared with 13, we will get 12, and the loop will break. We'll copy all the values of the right side array after this, that is 13. So 11, 12, 13. Okay, so we'll say while I is less than n1 and j is less than n2, if left array of I is less than equal to right array of j. If this happens, that means we'll copy the elements from the left array into the main array, which has an index k. Okay, array of k will be left array of I, and we got one element from the left array, right? So we'll increment its index I plus plus. Else, that means on the right hand side array we have the smaller value, so we'll say array of k is equal to right array of j, and then again j plus plus. Once this loop is added, so once one element is added, these two equations either from if loop or else loop will add one value to the array, ARR array. So we'll increment the k as well. We need to increment the k also, so k plus plus as well, so that this pointer on the main array will move to the next position. Or in this case, once we had copied this, we had copied these, we copied one here, then we move it to next one, then we move it to next one. So the merge sort has already an index of k. Okay, so one by one we copied from both the ends, but it could happen that either the left hand side array or the right hand side array still has some elements left. Okay, but only one of the arrays would be left with elements, not both, so we can simply copy them. So let's say copy remaining elements of left array. So we'll say while I is less than n1, array of k is equal to left array of I, then I plus plus k plus plus, right? Similarly, copy remaining elements of right array, so we'll say while j is less than n2, array of k is equal to right array of j, and then j plus plus k plus plus. Okay, now once we have all the functionality, almost our code is sorted. Okay, so we call the merge sort. It divides it into two halves. It finds the midpoint, divides it into two halves, first half, second half, and then each two halves are recursively divided until it reaches the end where left is no longer smaller than right. So when the merge sort returns from left hand side, it will have only one element, that would be, let's say, 12, and it will be getting compared with 11. So 12 and 11 will be merged into one. So what will happen is, I'll remove this right side quickly. I am very sure that it is clear to everyone, but still, okay. Okay, so if we go down, in the end we had 11 and 12 separated, right? So left hand side will have 12, and right hand side will have 11. So they will get merged and form another array 11, 12, right? Similarly, it will happen for 5 and 6 also. It will happen and after 11 12 are merged, it will happen with 13. They will be merged with 13. On the other side, by now 6 7 and 5 are done. 5 here, and in the end these two will get merged again. Okay, so first recursively sort them to the smallest element on the left hand side, the right hand side, and start merging them also recursively. Okay, what else do we need? Okay, we'll make another method for printing it. We'll call it function to print the array. Okay, public static void print array int arr, and we'll say for int j or int element from array system.out.print j plus some space. Okay, yeah, I think we'll pull this out, command x. Okay, we'll write our input and we'll run this method. We'll say merge sort what should we call it? Sorter is equal to new merge sort. Okay, int array is equal to 12 11 13 5 6 7. Okay, we'll say now that we have the print method outside, system.out.println, you can say given array, and we'll call print array, pass the array. Okay, in the end sorter dot merge sort will pass our array left index 0, right index array dot length -1. Okay, and then system.out.println sorted array, we'll call the print method again, print array, will pass the array. Okay, let's quickly run this. Java cannot find a variable j. Why? What's wrong with j? Okay, wait, element. Let's run this. Okay, let's little bit neatify it. System.out.println. Okay, let's run it again. Okay, so we have the given array and the sorted array. Okay, merge sort is really important, so please go through this video very carefully. In the end, time complexity, of course the time complexity of the algorithm is O of n log n. So if you see here, first we are doing the divide, that brings us the O of log n time complexity, and for each O of log n time complexity we are doing a merge, and the merge is dependent upon the value of n. So it will be O of n log n time complexity. Space complexity, of course O of n, due to the use of temporary arrays that we are using here. If you see, we are using left and right sub arrays. These are the temporary arrays. They will be created again and again, and the size of them depends upon the size of n. So space complexity will be O of n. Pros, of course, guaranteed n log n time complexity. Yes, it is a stable sorting algorithm, as we discussed earlier. It is really efficient for large data sets because of its better time complexity of n log n. For merge sort, bubble sort, for insertion sort, selection sort, and bubble sort, the time complexity is O of n square, and merge sort is n log n. So merge sort is very advanced and in terms of time complexity a lot better than the other three sorting algorithms. So it is efficient for larger data sets. Cons, of course, it requires extra space since it's not a in-memory data sort. so it makes it less efficient for space limited environments. Not an in-place sorting algorithms, it actually is the same point. It requires extra space for merging. Okay. So that's all from today's video, everyone. If you have anything, please let me know in the comment section. If there is any doubt, please call out. In the end, please, thank you everyone. Please like, share and subscribe. Thank you.